Hello and welcome class to this session. So this time we're going to discuss the other types of annuity. We have the deferred annuity and the annuity due. So last time we had discussed the ordinary annuity and we have introduced the important formulas and concepts. So this time we have these learning objectives. So at the end of the session you will be able to first familiarize yourselves with the definition and formulas involving annuities, particularly deferred annuity and the annuity due. So secondly, construct cash flow diagram and then solve problems on deferred annuity and annuity due. So let us start with the deferred annuity. So it is one where the first payment is made several periods after the beginning of the annuity. So let's say we have here a cash flow, okay, and then several periods before the annuity will be occurring. So it's not necessary at the first or at the present time. So it will occur several periods. Say this is our P. Say we label this as M periods, wherein on that period or that range there is no annuity yet. And then there are another set of period here after the M periods. This is where the annuity will begin to occur. So there will be series of payments here now, and this can be labeled as N periods. N periods are the zone or the range of periods wherein the annuity occurs. So notice that your annuity, the beginning of N period, is just coinciding with the last M period. So in short, we treat this as ordinary annuity. So remember ordinary annuity that we should allot one period before the first payment, okay, because the payment is occurring at the end of each period. So meaning, yung start ng annuity on the end periods, when we treat this as ordinary annuity, then itong one na to, yung beginning niya is at M. Okay? So at M. So that we're gonna pass through that timeline, and if we are concerned with the P or the present value, we can use this timeline and then further move that payments up to the present time. Say this is the backwards calculation from the future up to the nth annuity or up to the last payment brought to the M period, and this will be treated as ordinary annuity. We have the notation A times. So if this shall be labeled as P1, we can say that the notation to be multiplied by the annuity here is finding P1 given A at I% at N period. So these annuities will be brought at M with this notation, and it will be taken as P1. Okay, so P1 na siya brought to this M. And then further, P1 will be brought to the present so that it could coincide to our present. Say we'd have this timeline and then this arrow. So what we do is to bring this P1 up to P so that we multiply P1 to a notation that is involving compound interest. Compound interest because wala nang annuity dito, M periods will have a compounding rate of interest on these M periods. So we have the future to be brought to the present. So we have finding the present given the future at I% at M period. Okay, so let me just arrange that one. So here it is, and then actually P1 is this expression, so we just substitute that value to P1 and then just copy this notation. Okay, so as simple as that. If we need to deal with the future, we will do the same principle here, and actually mas madali yung treatment ng future because we will just transfer the timeline on the future, and if you notice, we are now dealing with only annuities at the end periods. So basically this will be treated as a ordinary annuity. All of those will be brought to the future, and we can say that A times finding F given A at I% at N period. So what is essential here, as I have said, is that we need to go one period before the first payments, because this will be treated as ordinary annuity, and the ordinary annuity is the payment will occur at the end of the period. So you need a 0 period for 1 for a first period. So kapag nakakita ka ng 1, ipa-atras mo ng isang period para yun yung magiging 0 period ng 1 wherever it is. So that's the technique in ordinary annuity. So it's very easy to treat this as ordinary annuity. Okay, so that is, so the only difference of ordinary annuity and deferred annuity is that magkakaroon ng several periods before the first payment occurs. Unlike ordinary annuity, at the beginning or at the end of the first period, there will be payments until N. Okay, so the treatment is just you establish your cash flow correctly and you will not get lost. So let us have example. Okay, say for the first example, on the day his grandson was born, a man deposited to a trust company a sufficient amount so that the boy could receive 5 annual payments of 10,000 pesos each for his college tuition fees starting with his 18th birthday. Interest at the rate of 12% annum was to be paid on all amounts on deposit. There was also a provision that the grandson could elect to withdraw no annual payments and receive a single lump amount on his 25th birthday. So the grandson chose this option. Letter A, how much did the boy receive as the single payment? And letter B, how much did the grandfather deposit? So it is a trust fund actually. He need to invest a certain amount at present time. So parang parang insurance, a plan so that on the 18th birthday of his grandson, he will begin to withdraw 10,000 pesos from that 18th birthday onwards up to 5 consecutive withdrawals. Or he could elect to withdraw no annual payments, or he will just get it on a single time. Okay, so on the 25th birthday. So instead of withdrawing 10,000 from the 18th up to 18, 19, 20, 21, 22. Okay, 18 to 22, that is 5 withdrawals. Instead, he'll just sum the amount on his 25th birthday. And the grandson actually chose this option. So what is that amount that he received on the 25th birthday, on his 25th birthday? And letter B, how much did the grandfather deposit? So here it is essential that first we must have to establish our free or cash flow diagram here. So let's say we have here the timeline. So at present time, the grandfather should have an investment. Okay. So that starting counting from this present time up to the 18th birthday of his grandson, the grandson could withdraw 10,000 pesos. And that should be 5 consecutive withdrawals according to the condition. So from 18 to 22, there will be 5 consecutive 10,000 withdrawal. But the provision on the trust fund is that the grandson would have an option to not to withdraw from 18 to 22, but rather have it on a single time, on one-time withdrawal. So one-time withdrawal on the 25th. Say this is F. So what we do here is to get the equivalent of these annuities to be calculated forward to the future. So what we do is to treat this annuity into ordinary annuity. So from 18, saan tayo magsisimula? Wag sa 18, but we go one step backward. So mag-start tayo sa 17. Say this is the period. Of course, we will terminate up to the range of your annuity, which is this one. So we're gonna have a forward calculation here. We can say that 10,000, and then if I'm going to label this as F1, so we have the notation finding F1 given A at 12%, and then at 5 periods. So this will now be the value of F1. So that notation. So further, that F1 will be brought to this. Okay. So we have that arrow. Then we say F1 times finding F given F1, 12%, and we have 3. Why 3? Because we have 3 periods, say 23, 24, 25, after the last annuity here. So we have 3 periods to bring this F1 to this F. Further, we can say that this F1 is actually that notation. So ito yung F1, ano? So 10,000 F1 given 8% 5, then we have finding F given F1 12% 3. So now this will be our solution. So for letter A, we have F is equal to 10,000, and then what will be this notation? So this is a forward arrow. So what we use is the forward notation, that is finding the future given the present. On annuity, say 1.12 raised to 5 minus 1 all over 0.12. Then this notation is a compound interest notation equivalent to 1.12 raised to 3. So if we're going to compute that, we have 89,252.93. So this is the amount the boy received as single payment on his 25th birthday. So if we know this future, then it would be very easy for us to determine P. Say letter B, we'll just use the compound interest wherein the future will be brought at the present, okay? Say P here is equal to F times finding P given F at 12% at 25 periods. So we get P, first we substitute F, and then this notation, that is 1.12 raised to negative 25. So we have here 5,250.15. So this is the investment of the grandfather in order to come up with this withdrawals and the future of his grandson. Okay, so for problem number 2, so we have if 10,000 pesos is deposited each year for 9 years, how much annuity can a person get annually from the bank every year for 8 years, starting 1 year after the 9th deposit is made? So essential here is to establish our cash flow diagram. So we have here the cash flow diagram. So for 9 years, you're going to deposit 10,000 pesos. So when we say deposit, that will be a cash outflow, or that is going downward arrow. Say this is 10,000 deposited for 9 years. So right after this, you will start to withdraw or to get an annual withdrawal from a bank for 8 years. So that is 1 year after the 9th deposit. So this is the 9th deposit. 1 year after will be the 10th year, where you start to get an annuity for 8 consecutive years after that 9th deposit. So the question here is, what is that equivalent annuity for this equivalent equal payments made for 9 consecutive years? So what you do here is to first select your timeline, or the most convenient timeline. We can work on this cash outflow and cash inflow, because we equate this cash outflow to the cash inflow at a common timeline. So basically, you might want to select your present time for this cash flow to meet at that selected reference, say this one, present time, or you might want to select the future time, or you might want to select the time between these two annuities. Okay, so the most convenient timeline is the 9th year, since dito magsasalubong kaagad yung cash outflow annuities and cash inflow annuities. Now I'll just copy this one so that I'll also present here another solution wherein I'm gonna select the present time as my timeline. But for the meantime, we will work with this cash flow, wherein I'm gonna choose the 9th year as my common timeline for those cash outflow and cash inflow. So all of this will be brought to this timeline. First, I'm going to bring this annuity to the timeline. Say I'm going to have A times finding P given A at 14% at 8. So let me reiterate here on the green A here, yung mga annuity ng green. It was treated as an ordinary annuity. Wag sinabing ordinary annuity, the payment occurs at the end of the period. So yung 1 mo aatras ng isa dyan, so that your timeline will be 9, coinciding with the 9th. So there will be 8 payments out of that. Okay? So, yung future, sagad naman yung future dyan sa A. So, next is to also bring this cash outflow to this timeline also. So, basically, you need to move backwards from the 1. Okay, dito. Atras ka ng isa. Dito mo sisimulan yung forward calculation up to that point. Let's say we have that arrow. Then we say 10,000. Finding F given A at 14% at 9. So, we iterate that if I'm going to label this as F1, F1 shall equate to 0. So, ibig sabihin, lahat ng pababa will be equal to cash inflow or the upward arrows. Okay? Cash inflow. So, ibig sabihin, parang quits lang yung pagbayad at yung earnings ng withdrawals. So, kapag nagsalubong sila dyan, pababa minus pataas, equal to 0. So, meaning, downward cash flow is equal to upward cash flow at a common timeline. And your common timeline is this yellow mark here. So, let us have that one in this. So, unahin muna natin pababa. We say that 10,000 is equal to, what is this? F given E at 14% and then 9. And this must be equal to the annuity P given A at 14%, 8. And then by this, we just copy and then insert the formula F given A. So kapag F given A, that is a forward arrow. And we know that forward arrow, we have the notation or the formula 1.14 raised to 9 minus 1 all over 0.14. Then for the right hand side, we'll just copy this unknown A and use the formula P given A 14% at 8. So this is a backward arrow. So when we say backward arrow, we have a formula of parang magbabaliktad 1 minus ayan 1.14 raised to negative 8 or negative yung exponent mo dito and divided by 0.14. So we have this value as 4.64 and that as 16.08. So we'll have an annuity of 34,675.19. So as an alternate solution, again, you can use another timeline. Say you're gonna choose this present time. So first you bring this 10,000 disbursement to the present time. Say we have 10,000 times P given A 14% and 9. So for these annuities, we need also to terminate at the 9th period because ito, from the first payment, we need to go backwards one period so that we can have this reference for this range of annuity. So we're gonna use this portion before we can backward it to this period or the present time. So bring that one. Say we have A, finding the present given A 14%, 8. Then this one will be brought further to the period. Say we just copy this. Okay, so A, P given A, and then we multiply this by the single payment present worth factor by compound interest. And that is 1.14 raised to negative 9. So all of the cash flow and inflow was brought onto this timeline you've selected. So all we need is to equate them. So here, then we substitute the formula. So finding P given A, we have a backward arrow. So we have that 1 minus 1.14 raised to negative 8 as this formula. Okay. So the same formula will be used in here because we have a backward arrow and finding P given E. So, but in here we have different period, -9 all over 0.14. So, if we are going to calculate all of this, we can solve for A here, and it will yield to similar or the same figures or answer. Okay, same answer as the first solution. So this will be an alternate solution. So you can also choose the future, and I think that should be your exercise to do. Select the future in order to solve for A also. So this will be the solution for the second problem. Okay, so we proceed to another type of annuity, that is the annuity due. So the annuity due is one where the first payment is made at the beginning of the period. So it is um, different from ordinary annuity. So yung ordinary annuity, yung payment is occurring after the period. So this time, the payment is occurring at the beginning of the period. So putting that into cash flow, we have this cash flow up to end period. So your annuity will occur at 0, no? So sa simula pa lang meron ng payment or at the beginning of the period. And then it will terminate not on the end period but n-1 period. So that is annuity due. It differs from the ordinary annuity. So yung ordinary annuity will terminate at n, but annuity due will terminate at n-1 because the first payment occurs at 0 or at the beginning of the period. So how shall we treat this one? Now, if we are concerned with the present equivalent of this, say the P equivalent, we will just treat all of this from 1 to the n-1 as ordinary annuity, kasi patras tayo dito, and then just add the annuity that is coinciding at the present period. So all of this shall be brought to the present time. So if this is the case, we say that A times finding P given A at I% at n minus 1. So the present worth should be equal to the initial A here, okay, remember my A dyan kanina, plus this one. Okay, so this will be the formula for annuity due considering the present worth. Hence, it can be expanded to this formula. Okay, palitan mo lang ng n-1 yan. Okay. So, what about for the future? If we are concerned with the future. So, we take this as our timeline now and consider for the F. And by the way, in this derivation, we should consider N as our termination point for the future. Then we will bring all of this annuity to the future. But you cannot directly do that because you should terminate at this point kasi hanggang dito lang yung A. So we consider that timeline and terminate at this point for a while. So for this timeline, we have A times finding F given A at I% at n-1. But considering this, we also have another A here. So we need to add plus 1 because of this. Okay. Kasi on the ordinary annuity, supposedly hanggang dito lang, wala dapat dito. So since we have this one, we add plus 1 here. And then close that. Then for this timeline or range, we have copy this one. Okay. And then we multiply it by single payment compound amount factor. We have 1 plus I raised to n, but n here is having a difference of 1. So we can just omit that one. Okay. Then, obviously, that will be cancelled. So we can cancel that one. Okay. We can now omit that one. Then we substitute the formula of this. We have 1 plus I raised to n minus 1 all over I times 1 plus I. So this time we are going to distribute this to the first term and the second term. We have 1 plus I raised to n plus 1 yon, less 1 plus I all over I. Then we distribute this negative sign on the inside terms and then group it. So minus 1 yan. So naiwan minus I all over I. So it is found here now that this notation is equivalent to this. To equivalent to f given ai per set n plus 1 to minus I over I is 1. So that is multiplied by a. That equates to the future worth of the annuity due. Okay, so that's all the derivation on the present worth and the future worth of the annuity due, where the first payment is made at the beginning of the period. So here, no need to worry about this formula. Basta alam niyo yung ordinary annuity. Sa ordinary annuity, just stick to the ordinary annuity if you do not want to memorize this formula. Just stick to that ordinary annuity formulas and just add additional annuities that are coinciding with your reference timeline. Okay, so we'll have examples now. For the first problem on annuity due, we have problem number 1. Miss Banato bought an equipment costing 60,000 pesos, payable in 12 quarterly payments, each installment payable at the beginning of each period. So from the problem itself, it mentioned that the payment will occur at the beginning of the period. So this is an annuity due problem. So we have here a rate of interest of 24% compounded quarterly. What is the amount of each payment? So if we are going to look at the cash flow diagram of this problem, it must be clear that the equipment is costing 60,000 pesos, but it can be paid in a 12 quarterly payments, wherein the first payment will occur at the beginning of the period. So we note that at the present time, at year 0, there will be already a payment because the payment occurs at the beginning of the period. Hence, it shall occur on the 11th period, although that is quarterly, 11th period. Why? Because, counted na yung isang payment at the beginning of the period. That is why, in your formula, we can get P is equal to A, this initial A here, plus A, then finding P given A, then we divide our nominal interest rate to 4 because it occurs 4 times in a year. So we got that to be 6%. We can place it here. And our period is n minus 1, wherein this is 12 minus 1 is equal to 11. So we substitute the value of the present worth, and then that is A plus A times that factor, and that factor is actually bringing all these payments to the present time. So we can say that this is A, P given A, 6%, and that should be 11. So we continue with this formula. This is 1.11 raised to negative 11. So I'm sorry, this supposedly is 0.06 all over 0.06. Then we can close that one, then compute for that factor, and this shall yield to 7.89. So we just add plus 1 here, the coefficient of A, then divide that sum to 60,000, or 60,000 divided by that sum is equal to 6,751.53 pesos. So this is the equivalent annuity for the 60,000. If you're gonna pay that into 12 quarterly payments with the payment occurring at the beginning of the period. Okay, so let us move on to the next problem. Say a certain property is being sold and the owner received 2 bids. So there are 2 bidders here, no? The first bidder offered to pay 40,000 each year for 5 years, where each payment is to be made at the beginning of the year. So may I correct this to be 400,000 each year for 5 years? So of course here is gonna pay for 5 years, but at the 5th year there will be no payment since it was counted on the 0 or at the beginning of the period. So this is the offer of the first bidder, and then we will just compute that in a while. So first we're going to also establish the offer of the second bidder. So we take note on the offer of the second bidder that all payment should be made at the beginning of each year. So basically the first payment on the first year will occur at 0. So at 0 he offered to pay 240,000. See the beginning of the 0 or the 0 period. Then 360,000 on the second year, but at the beginning of the period of second year, that will occur on the first year. And then 540,000 from the beginning of the third year and the next 3 years. So this will be the offer of the second bidder. So in here you have 2 options. You are going to compare the present worth of both cash flow or both offers, or you may compare the offers in terms of the future. Okay, so in here I'm going to compare the cash flow of the offers in terms of the present value. So I'm gonna set my timeline on the present time. So all annuities from 1 to 4 will be brought to 0. See, we have 400,000 times finding P given A. So cost of money is 20% compounded annually. So we'll place 20% on that. And then how many periods? 1, 2, 3, 4. So that period is 4 for this. And then we just add it in a while. So if you notice, 400,000 5 years, your N here is 5. So we took 5 and then we less 1. So yun, yung annuity due is we take N and then less 1 for that N, since the first payment is occurring. Parang nag-transfer yung payment, instead nasa N siya, nandun siya sa first or the present time. So this is the approach wherein the present worth of the A, say this is offer A, is equal to, initially we have A here, perhaps we can put it here, the value. This one 400,000 plus 400,000 times this notation. So this is a backward arrow, so we have the formula 1 minus 1.2 raised to negative 4 all over 0.2. So we calculate this value. We have 2.589. Then we can calculate now our PA to be equal to 1,435,493.83. So it is a decent offer, but we cannot decide yet because we need to also compute for the present worth of the second offer. So perhaps we can move it here. Okay, so the first value to be computed back to the present time or zero time or year zero. The 360 mo namin. So we bring that to that year zero. So 360,000 times finding P given F at 20% at 1 period. So next is meron tayong uniform payments here. If we treat this to be ordinary annuity, atras lang tayo ng isa, okay, and then we will use this year 1 as our timeline, okay, to bring this annuity on the present time of that range and then further bring it to year 0. So here it is. We're gonna bring that annuities into this period first. Say 540,000 times finding P given A at 20% at 3 periods. And then we will bring this further into this year 0. So may I just have this notation. First, we're going to copy this and then we will multiply it by a factor, that is a compound factor, and that is single payment present birth factor, and that is finding P given F at 20% at 1 period, and then we close that. So we denote this as present worth of B or offer of B. So computing for PB, we have equal to, we copy this one, then we add this, and then add this 240,000 that is coinciding this year 0, and just substitute all of the formula. So this formula is finding P given E at 20% 3. So the formula here is going, the arrow is going backwards. So we have a formula for that as 1 minus 1.2 raised to negative 3 all over 0.2. Then close it. And this one is 1.2 raised to negative 1. And then moving on to the factor of this 360,000, we also have that factor as 1.2 raised to negative 1. So by this, we can now compute the offer of B. We have 1,487,916.67. So we can now compare the offer of the first bidder to that of the second bidder. So the offer of the first bidder is 1,435,493.83, and the offer of the second bidder is 1,487,916.67. So therefore, the owner should accept the offer of the second bidder kasi mas mataas yung offer ng second bidder. Okay? So that's it for that problem, and with this we will be having an exercises next meeting, and thank you and good day.